Okay, so with this tutorial, we're going to be altering our current code that we have for the glow, and we're going to, instead of doing 4 writes to memory, we're only going to be doing 1. We're going to be writing, well, 4, 5, 6 writes to memory. We're only going to be doing 1 instead. So essentially what we're doing is we're going to be writing to the glow struct. And that's going to just really kind of help out a little bit in performance, as you can probably assume. Doing 4 just memory, well, yeah, Windows API calls is kind of slow compared to doing just 1. Sorry, 6. Keep making that mistake. So first thing that we're going to do to our project, we're going to use the updated mem files. We're switching over so we can use unicode. So all you can need to do is just download these from the link description. Go to your folder, just click and drag, and replace. Then once that's done, go up here to build, go to properties, go down here to character set, and switch to unicode. And once that's done, go over here to where you call your get process and get module, and we're going to change these to string literals. So just put a capital L right before the string, just like so. See, the errors are gone. Go ahead and build it, make sure everything's okay. And now we can move on. So we're also going to be using, instead of using dword, we're going to be switching over to int pointer t. So go ahead and replace everything you have that says dword. Well, that. And that should be all, just to make sure. Alrighty. So, and one thing, this is very useful, and Frank ended up actually posting a tutorial on this, which hopefully he will link down in the description of the video as well, for the written version. And instead of having to constantly, I'm assuming most people that are watching this are using haze dumper to get whatever offsets they want, instead of going through when you have a big project, you have several dozen offsets or more. As you can probably assume, if you don't have a pattern scanning function, this can get kind of annoying. So instead of having to go through and manually manually change each offset, what we can do is you can even download the csgo.hpp file from the GitHub that is used for this. Go ahead and copy the file. Go to your project where your normal .cpps are. Paste it in there. Go over here to header files, add existing item, and add the csgo.cpp file. Now once that's done, we're going to go ahead and include it, csgo.hpp. And here's an example on how to use this. Let's say we have our local player here. What we can do is type hazed dumper, 2 colons, and local players should be under signatures, colon, colon, and you can see a huge list. These are all the offsets. So we just type local. You can see right there, DW local player. We're going to go ahead and do that for the rest of these. The entity list is netvarse. I stand corrected. Add the entity list. Go ahead and add the glow object man. Damn it, it's the wrong one again. Glow object manager. Glow index, which I should have seen under netvarse. Haha. Alright, and team. Oops. And I'm an idiot. Team num. Okay, so now whenever you want to update this or change it, all you simply have to do is just replace the csgo.hpp file. Go up here, simply rebuild your project, and you're good to go. Assuming the haze dump that the offsets from the haze dumper are correct. So now we need, let's see, we need to add one more offset, is defusing, because in this, and health. What we're going to end up changing as well while we're doing this, we're going to make a function that will pretty much create our glow structure for us. That's what we're going to write to memory. Now in that, we're going to make it so the enemies, they glow solid green when they're at 100 health. But as that gets lower, it slowly transitions from green, then around the 50% mark, it's more so yellow, and then it's going to get down, once it gets to very low health, like sub 40 and so on, it's going to turn to red. And I will show you what I mean by that. As you can assume, I have it here. So we have our health. So for instance, the red color, when they're at 100 health, we want that to be 0. So let's say they drop down to 80. So red would slowly be incremented just a little bit. So we take our health, 80, we multiply that by 0.01, turn that to a negative, then we add 1, we got 0.02. So that little 20 number increase, or decrease, I'm sorry, has resulted in a bump up in red. And green works the opposite way, except it's just in the exact opposite direction. So if we take 80, we multiply that by 0.01, it's 0.8. So it's still more green than red, but it's slowly transitioning to yellow. And in case you didn't know, yellow is green and red combined. So if they're at the same value, it's going to be yellow. So need to add health. So uint pointer t health equals haze dumper net bars health, and we need to add the is spotted offset. So yeah, just call it the same name, is spotted. I'm in the wrong, wait, am I in the wrong section? Spot, nope, yep, there it is. Sorry, it's just called spotted. Okay, so we have the offsets that we want. So now we want to actually create our glow structure that we're going to write to it, which I'll give you an example of here in a second. So yeah, we can just do it right here. Struct glow structure. And let's just call it glow struct. Alright, so, and our name to reference it, I'm just going to call it glow, just call it glow. So, what we have here, we have our base. So, since, as you can see, where I'm at, down here, when we write to it, the reason we're adding, well, we're going up by 4 bytes is because we have the base in the way of the structure. So the base has, I don't remember what exactly it is, but whatever it is, it takes up 4 bytes. So that means it's like an integer, float, something along those lines. So if we didn't add 4 bytes to this offset here, we would be writing at the base. But instead, we want to write to what controls the red color. So we add 4 bytes. And in order to get to green, well, we already have gone 4 bytes into it, so we need to add another 4. So that's 8. And then to do the next, as you can guess, since it's hexadecimal, it'll be C. Then, as you know, the range, 0 to like 15, and then reverse back to 1. I probably screwed that up, but I'm trying. So we're not going to be messing with the base at all, so we can just make it a buffer. Well, we can use a byte array as a buffer. So you can do that by either do just a Boolean array, for example, which is also 1 byte. As you can see, these are true or false, so they're 1 byte in size. You can make a byte array, which is also 1 byte in size. So you can make a byte array of 4, or you can do an integer, for example. So an int alone, that just takes up 4 bytes. So what we can do is int base, that's it. We are now at the red mark right here. So what we can do is we have our red, so we know red is well, as you can tell by writing to it, that they are floats. They go from the range of 0 to 1. So we're going to do float red, float green, float blue, float alpha. So that has our red, green, blue, and alpha. So then we have an 8-byte buffer of crap that we don't need, so we can just do an int array of 2. So buffer 2. or just to show you what I mean, byte array of 8. My opinion, I just prefer to kind of go that route. It's cleaner to me. So then we have, and I wrote forgot, so yeah, we're just gonna add another buffer. Buffer2, size of 4. And apparently there's another buffer right after it, so instead of doing multiple ones, we can just do 8. So if you can count this total, 8 plus 8, 16. And go ahead and get rid of that buffer. So now we have render when occluded, and that's a boolean. So bool render when occluded. I'm hoping I'm spelling that right. By default, that's true. So then we have render when unoccluded. Just gonna copy this. After that, we have our full bloom, which I believe that's also boolean. Full bloom. Then we have a 1 byte buffer. So byte buffer 1. So that's moving us down 1 byte. Then we have bloom stencil, which I don't know exactly what type that is, and we're not going to be messing with it. So we're going to do a byte array of 4. Then we have our glow style, which is kind of cool when you tinker around with it. So glow style. So to follow along, we are completely just starting at the base, so we're not going to be doing anything with that, although we're just going to have it there. Since we're not going to be doing with it, might as well change that into a little buffer. So start out like what we actually change. We're changing red, green, blue, alpha. We already know we're not going to tinker with any of this, so we're just going to make it a buffer. We'll use that as a buffer, and that's going to put us right all the way to render when occluded. So we have a buffer of 8 bytes. I don't remember what this was, so we're doing another 4 bytes, another 4 bytes, so 16 bytes total. That leads us to render when occluded, which is 1 byte, and that's a boolean. Booleans are 1 byte in case that wasn't clear. We have render when uncluded. Then we have full bloom. And full bloom is that, like, when you really illuminate the living crap out of the enemy with whatever color you want. Like, it kind of overdoes it, and I personally really hate it. But, yeah, to each their own. Then we have our other buffers. So you can probably count. That would be 5 total. So we have a buffer of 5 before we get to our glow style, which is something I want to show at the end of this video as well. So this should essentially just be our glow struct that's ready to go. That should have taken care of those two. Yeah, now. Good enough. Alright. So now we want to make a function that pretty much is going to handle our glow. So I called it handle glow, void handle glow. And we want to have a way to call it. But for now, we already know we're going to be taking this code and modifying it. So we can go ahead and take it up and throw it in here. And just for reference of the example at the moment for testing, we're just going to go ahead and have it be called each time. So now that we're in here, we get our team, we get our glow index. Well, the only thing we need to focus on right now is our team, because we're going to make it down here as well. Yeah, either do that, or we're just going to use a simple if else, and we're going to make 2 separate functions. Just I feel like that's going to be a little bit easier to read. And as well, if you're getting to this point where you can pretty much do this on your own, you should be able to alter this however you want. And alright, so I'm going to call one just void set enemy glow, and another one void set team glow. Oops, don't need to make a prototype. Now we already know we're going to be altering, at least for the enemy, we're going to be altering its color. So that's going to be based on the health and everything. So we're going to be making one up, just instead of having this be cluttered up, we're going to have a function that is going to alter the glow struct for us. And, well, do what we want. So we can do, we want it to return a glow struct. So the type glow struct set glow color. And we know we want it to take in health, so int health, and just allow us to compile. Just make it return dist. Alright. Let's do occasional build. Yeah. Yeah, 1. There, satisfied. Alrighty, so go ahead and get rid of this. Go ahead and get rid of this. And get rid of this. So we have our if-else statement. So, obviously, if our team equals the entity team, we would call set team glow. So, set team glow. And we're going to be writing it to the entity. So, one thing that we need to pass in is the entity, which is, so I could take in uint pointer t, call it entity. One thing just for reference, so I can be lazy. And I realize I just undid what I did, so So set team glow entity int pointer t entity. Alright, so if they are on our team, we're going to be passing that in. And I'm assuming we're getting our team here as well. Yes, we are. Sorry, it's been a couple months since I've actually even looked at any of this. Alright, so now we need to do the same thing for the enemy. So set enemy team. We're going to pass in the entity. Come on. Oops. Nailed it. There we go. Okay. That's gonna go. And okay. So we're gonna start with the team first. Now what we want to do, we want to actually first read in the glow structure. So what we can do is just for now, glow struct t glow. So t glow equals man dot class. Okay, what I call it? Yeah, it's mem class dot read mem glow struct, because that's what we want to read it in as. Then we have the address, and the address is glow object blah 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 blah. So we need to figure out a way to simply just get the glow object. Well, since we're you can obviously easily change all this to run it how you want it, but I want to make it just be stored in our val structure here. So val.glowObject. So that's always going to be there. Let's make it a little easier. So val.glowObject plus, now we need the glow index, which is there. Alright, so we can also just simply pass that in. So int glow index, int glow index, glow index times 0x38. So this should read everything about our player right now, and that's a glow structure anyways, into our structure, which is called tglow. Keep in mind, I'm just kind of winging this as I'm going. I just wrote this to kind of keep you on track. Alright, so now what we want to do is we want to modify it. So since this is just our team, what I personally use is just blue for team, And for the enemy, I do the health based and the check if they're defusing the bomb, for example. So what we can do is glow dot blue equals 1.0f. Well, just make it clear that's a float. Now we need to do the alpha. So glow dot alpha equals 1.0f. Now we need to set the render when occluded and unoccluded. So glow dot render when occluded equals true. Glow dot render when unoccluded equals false. Alright, so now once we essentially have our new glow structure, it should be glowing bright blue. We write that back into memory. So class dot write memory glow struct, remember the type, and the exact same thing as above. So val dot glow object plus the glow index times 0x38. And we want to set that. Oops. Wait. Nope. Yep. Now we want to set that equal to glow. Why did I write equals? Alright, so now hopefully when we run this, it should make this guy glow nice and blue. Unless there's an issue. In which case you'll get to watch me fix it. Yep. Cool. Actually worked first try. Alright, so now we need to do the same thing for the enemy. Which now that we have all this, we can just simply copy and paste it. Change this to glow for enemy. So now that we've read in everything, we can call glow struct, and just call it glow. Alright, so it's going to take, what, can you not do that? Glow struct str. Alright, so we write in our glow structure, call it glow. We want to call that glow, pass in our current glow, and do all our crap from there. So glow equals set glow color glow, and we want to set in the health of the enemy. So what we can do, int health equals class dot read mem, type is an integer, and it goes off of the entity plus offset dot health there. So we're going to pass in health. So we can go ahead and get rid of this. Go ahead and do a quick build. Alright, let's go ahead and get rid of this. Just going to call it, we don't want to do any of that. So we're going to have it return glow. So we're going to set, what was it? Alright, so for red, we only want to set red, green, alpha, then the rendering when occluded and unoccluded. So we're going to do all that in here. So health, red is health times negative 0.01, then we add 1. So glow dot red equals health times negative 0.01 plus 1. Glow dot green is ty equals health times 0.01, I think. Yeah, health times 0.01. Then we want to do our alpha, so glow dot alpha equals 1.0f. Then glow, well, just to save time again, set our render when occluded and render when unoccluded as so. So we have our new glow. Now we want to write it to memory, which, just like with our team, we can simply copy it, paste it over, change that to glow. So now we should hopefully be good to go. Go ahead and run it. Yep, He's glowing. Sure they are, and they are not. Alright, so let's find out why that is. I'll go ahead and pause the video while I figure this out real quick. Well, that didn't take very long. Da-da. And as you can see, they're glowing just like so. Shoot them. Slowly transitions down to red.
Stay sharp. Still one left. Counter-terrorists win.
So now what we want, I'm gonna go ahead and switch teams for this. Hopefully it does. There we go. Alright. And as you can see, teams transition to their appropriate colors, and they're both alive. Alright, so for this, now that we have, well, we're setting our color for the enemy at the glow, what we want to do is, this is what I personally like to do, is if they are diffusing, I like to make them glow solid white. So that allows me to kind of just have a little bit more of an edge. You can be able to tell if they're diffusing, like, and holding it, or if they're faking it, and so on. So what we can do here, this is incredibly simple. As you can see, there we are. So all we have to do is, well, instead of doing the health directly, we're going to, like I said, I'm just kind of winging this as I go. We're going to go ahead and get that, but we're going to get that up there. What we want to do, we want to pass in the entity. So instead of passing in enter T entity, now let's go ahead and get the entity's health. So what we want to do, we want to use the, where's the diffusing, damn it, is diffusing. I don't know why it is spotted. So is defusing. So we're here in our glow, we can check if the entity is diffusing. So bool is diffusing equals mem class dot read mem. Remember, it's boolean. It would go by the entity plus offset dot is diffusing. So if is, let's just call it diffusing. So if they are diffusing, run this block. Otherwise, man, I really hate how plus formats that. Run this block. So in here, help, we already got our glow. So glow dot red equals 1.0f. We're gonna go ahead and copy this 4 times. 2, 3, 4. Change this to green, blue, and alpha. Then, so we don't have to do this twice, put this outside of our if-else statement, and when the entity is diffusing, they should glow solid white. So let's go ahead and test that real quick. But stop.
Activating the bomb.
Hopefully they run right to it.
Bomb has been planted.
I think I said one expert. What are you doing? Yep, as you can see, glowing nice and white. Really. And he's holding it. Holding it. And
Terrorists win. We're going to do this.
as you can see, that's how that works. So next, I want to show you just something else, even though it's not really
Come on, let's go.
very important, which is kind of cool. Well, let's go ahead and head over here to where we can see him visibly. Let's say we want to do something a little bit different. Granted, you cannot see this through walls, but it still looks kind of interesting. The glow.glow style. First one I want to show you is 1. So let's go ahead and run that. And this is the pulse. As you can see, it kind of gives that little bit of a, well, it's literally pulsing. So this can kind of be used in place of, well, instead of having to actually hook something and manually do chams, this can kind of be a little bit of a balance between that, but unfortunately you can't write the glow outline as well. There's also one for 2, which is, I don't know, it just looks kind of different. Then I want to say there's a 3rd. Which is, I don't know, just kind of pulsing and doing other stuff. But I personally just don't play with that. I just do normal glow. That, and I have my own kind of set of ghetto chams without actually hooking, which will also be in a tutorial here soon. Anyways, hopefully you found that quite useful. Actually, I'm going to go ahead and do a quick little walkthrough. Right. Make it toggleable. Yeah. And I'll show you full bloom. I'll just go ahead and do that too. Full bloom equals true. Alright. So, one way you can simply, damn it, do to make things toggleable, you can do this a couple ways. So, first one being, well, just get key state. Go ahead and load into a quick wingman. So, if get key state, then the key we want to use. So I want to use the 0 on my number pad, so vk numpad 0. And if that is technically enabled, we're going to have it, I'll call our handle glow function. Yeah, there.
Let's roll.
Still running. Alright. So, numpad 0. Go ahead and run it. As you can see, when I press numpad 0, toggle's on. Press it again, toggle's off. So that's one way you can do it. Which I really need to start actually doing on my own personal stuff instead of the crappy way I'm doing it. By the way, this is full bloom that I was talking about. That, it's... Yeah, it's... No. Another way you can use get async key state. And have it simply toggle a boolean. And it'll do the exact same thing. Just like so. So, that's how you go through and do all that crap. But I would just recommend you use get key state. So what we're doing is, once the numpad 0 or whatever key you set in here is toggled, which you can easily find online, just a list of keys from Microsoft's website, or virtual key code, sorry. We call our handle glow function. And inside here, we do our typical loop. We loop through each and every entity. Well, less than 64, which are reserved for, well, us. Now, if the entity's team is the same as our team, we call our set team glow function. Now, we created our glow structure, which holds pretty much whatever we want to change inside of it. And we go ahead and, since we created our glow structure, this is currently, it's blank, nothing in it. So we want to fill it out. So we do that by reading in the current glow structure of whatever entity is being passed to this function. Then we modify what we want. Since it's on our team, I just like setting it blue. So we just change blue to 1, alpha to 1 so we can see it, and are both render when included and unoccluded. Then we take this glow structure and we write it back to that entity instead of doing, the 6 write to memory calls. Now, same thing for the enemy, except we have a function that takes care of that for us. The only reason I'm not doing a function just for our team is simply because we're not going to be doing anything different about it. Instead of having all this in there plus this, it's just a little bit easier and a lot cleaner in my opinion, and we can change it from one location without having to kind of go through the middle of another function. So we do the same thing. We read in the glow structure, and we call our set glow color function, pass in the glow structure we read in, so that is what the entity currently has. Then we pass in the entity, that we just read the glow structure in from, so that we can do a couple of things with it. First, we check if they're diffusing. If they are diffusing, we want them to glow solid white. So we just set red, green, blue, right to 1, same thing, just normal alpha. We can actually simply do down here. And I hate full bloom, get rid of that. So if they're not diffusing, then we want to make it go by their health. So we take their health, multiply it by a negative number, which turns that into a negative. In our case, we're multiplying it by 0.01. So if it's 100, it'll be 0. If it's 90, it'll be 0.01 when we add 1 to it. And same thing for green, we just do it the opposite way. And once that's done, I'm just going to simply write to their alpha, then do the usual render when included, render when unincluded crap. So what's nice also about the glow structure, as you saw, how I wanted to go that route and change the glow style, STYLE, we can do so without really having to make another write to memory call. All we have to do, just glow.glowStyle, and we can do what we want with that.